All right, let's go ahead and finish up Unit 2. So, when we are talking about reactions, dehydration, synthesis, hydrolysis, whatever the case may be, this is a reaction. Reactions are going to have rates. Now, these rates are going to be affected by concentration and temperature and something known as catalysts. So concentration, this one hopefully makes sense. The more you have, the more you're going to have collisions, the faster the reaction. Temperature also hopefully makes sense. The higher the temperature, the greater the collision force, the faster the reaction. Now, reactions take energy. There is what's known as an activation energy that has to be available, has to be overcome in order for a reaction to occur. And this is where catalysts come into play. Catalysts speed up, or actually, they speed up the reaction by decreasing the amount of energy that is needed. So they decrease the amount of activation energy, increasing the reaction rate. In biological organisms, humans, apes, dolphins, tortoises, whatever the case may be, we call these catalysts enzymes. So, a couple of things we need to be aware of. The substance that binds to an enzyme that an enzyme acts upon is referred to as a substrate. So anytime you see that terminology, we're talking about the thing that the catalyst is going to affect. Enzymes are always going to end in ASE and typically have in front of them what their substrate is. So, amylase is an enzyme that digests amylose, or starch. And as I mentioned, they decrease activation energy. And this would be some examples of, chart examples of how they do that. Okay, so enzymes are going to have on them what we refer to as an active site. This active site is going to be what the substrate binds to. When a substrate binds, it is a temporary bond, but when it is bonded, we call it a enzyme-substrate complex. Enzymes are not used up in this process. They are reusable. They are specific, or mostly specific anyway, at least. Enzymes are going to only bind to a specific or a similar enough specific shape. And they are affected by temperature and pH. Now, in theory, the higher the temp, the greater the reaction until it's too hot. So here's the thing. The optimum temperature for biological enzymes is going to be whatever that organism's body temperature is. So for humans, in theory, that's 98.6. Why do I say 98.6? Because depending on the generation, the average of the body temperature is going down. There was actually a study that was done a couple of years ago that looked at the average temperature, body temperature for each generation. So that 98.6 was actually determined back in the late 1800s, like 1880, 1890. And we've been using it ever since. And for the silent generation, 98.6 they found was still accurate. However, as we moved into baby boomers, and then into Gen X, and then into millennials, and then Gen Z, and then Gen Alpha, and I don't think we have another generation after that yet, we've noticed that the body temperature has decreased. And in fact, Gen Z and Gen Alphas, they didn't do it really with Gen Alpha, but with Gen Z, what they noticed is the average body temperature for Gen Z is 97.5. So a temperature of 98.6 for them is actually a fever. So, but here's the thing. Just because we see it happening doesn't mean we know why. and what effect that's actually having on our body. So, welcome to research. A lot of times you do a piece of research to discover you need to do more research. It's a never-ending cycle. But, so body temperature is the optimum temperature, and then pH is going to be dependent upon where that enzyme is located. If we're talking about enzymes that are located in the stomach, their ideal operating pH is actually going to be a pH of about 3. However, if we're talking about enzymes that are found in the small intestine, their primary or optimal enzyme or pH operating zone is going to be a pH of about 8-9. So it all depends on where they are. And that's going to finish up Unit 2. We will talk about enzymes more in further PowerPoints.